what feels illegal in math but really isn't?
So here's the setup. There is a secluded island with an unknown number of logicians. We know that these logicians can either have blue-colored eyes or green-colored eyes, but nobody actually knows the count. It could be that it's half and half, or all of them have green eyes, or all of them have blue eyes. And the interesting thing is that there is a very strict rule against knowing your eye color, because if you do that, then you have to leave the island immediately. For that reason, there are no mirrors, no reflective surfaces, water is contained in opaque containers, and discussions about eye color is taboo. But one day a visitor comes and, in the presence of all of the islanders, tells them that at least one of them has blue eye color. Now, this very profound statement sets a chain of logic and events. So the question is, what will happen next, and what is the future of the blue-eyed individuals on the island? Keeping in mind that even though they cannot know their own eye color, they can still see the eyes of every other person on the island. So, it is now time for the solution, and we'll start by imagining simpler scenarios. Case 1, we only have 2 people on the island. If person A has the blue eye color and person B does not, then person A will know their eye color immediately to be blue. And that's because they can see that person B has the green eye color. But what if both individuals had blue eyes? They will both know that the other person's eye color is blue, but they cannot be sure about their own eye color. So this time, neither of them can leave the island immediately. So they stay put. But the very next day, when they see each other, they gain new knowledge. That is because now they're thinking from the other person's perspective. Only reason each person stayed is because they saw each other's blue eyes. Because if they had seen green, they would have immediately left. The act of staying one extra day gives new information. So then on the second day, they both leave. Now let's imagine a scenario with 3 individuals. We'll call them A, B, and C. Since we have already discussed 2 people having blue eyes simultaneously, in this scenario, let's imagine that all 3 people, A, B, and C, have blue eyes. So let's think from the perspective of person A. He sees that B and C both have blue eyes. Logically, he cannot conclude that he also has blue eyes. But he knows that person B and person C cannot be sure of their eye color right away. They are also watching each other and him. So no one leaves the first day. The act of staying gives each person a new information that at least 2 people have blue eyes. And if 2 people in fact did, then person B and person C would leave the second day. But the fact that they don't leave the second day gives person A new information. He knows that he also has blue eyes. They're all watching each other, and every extra day brings new information. Guys, thus far I had only been discussing from person A's perspective. But the thing to note here, that person B and person C were also going through the exact same process. Although they knew that 2 people had blue eyes, they couldn't be sure about their own. But the fact that the 2 blue-eyed people did not leave until the 3rd morning gave each individual new information. And they all left on the 3rd day. And using inductive reasoning, we can see that the same logic would apply to a group greater than 3. If there are n people with blue eyes, then on the nth day, they will all leave. I find this riddle fascinating because it explores the concept of common knowledge. You see, the information wasn't contained in the initial statement made by the visitor. It was contained in the fact that it was told simultaneously to all individuals on the island. I hope you enjoyed the video, and if you have any questions, leave them in the comment section. Give the video a like and my channel a follow.